In our daily lives, we can observe patterns in natural as well as man-made objects. For instance, look at the child playing with his toy pyramid set. How many bricks will he need to finish the pyramid with one brick at the top? How many bricks will he have in the fourth row? Not too difficult to determine, is it? However, consider a situation where the pyramid is much higher, maybe 200 bricks. How many bricks would the child need for the 54th row? It's a little more difficult to figure out, right? You may often need to make such calculations, whatever field you choose to work. For example, in construction activities or even in financial matters, you will need to work with patterns. You need to learn to analyze and predict patterns, also called progressions, to be able to resolve such problems. Progression can be arithmetic, geometric, or harmonic. In this lesson, you will learn about arithmetic progression. At the end of this lesson, you will be able to identify an arithmetic progression or AP, define arithmetic progression, calculate the common difference of an AP, and derive and apply the formula for general term. To understand progression, take a look at some sequences. For example, consider the sequence 2, 4, 6, 8, and so on. You need to predict the fifth term in this sequence. If you analyze the sequence, you will find a constant between every two successive terms in the sequence. For instance, 4 equals 2 plus 2, 6 equals 2 plus 4, 8 equals 2 plus 6. As you can see, the constant is 2. Therefore, fifth term equals constant plus fourth term, which is 10 equals 2 plus 8. Now, let us look at another sequence with fractions. Minus 1 upon 2, 0, 1 upon 2, 1, and so on. In this sequence, the constant is 1 upon 2. Consider the following sequences 4, 9, 11, 13, and so on, and minus 8, minus 5, 0, 1, and so on. You can see that there is no constant between the terms in either of these sequences. Based on this data, it will not be possible to obtain the next term in any of these sequences because there is no visible pattern. The pattern in the first two examples shows that you can obtain successive terms by adding a fixed number or a constant to the preceding terms. Such a list of numbers is said to form an arithmetic progression. So, an arithmetic progression, or AP, is a sequence of numbers or terms in which each term is obtained by adding a constant to the preceding term. This fixed number or constant is called the common difference of the arithmetic progression. It is represented by D. Now remember, if D is not constant, then the sequence is not an AP. D can be a positive number, negative number, or 0. Consider the following problems regarding arithmetic progression. Find the sixth term in the sequence 2, 4, 6, 8, and so on. Find the 13th term in the sequence minus 15, minus 11, minus 7, minus 3, and so on. John is saving money in a bank. He deposits 100 rupees in the first week. Later, he deposits 25 rupees in the account every week. What will be the amount in his account at the end of the 20th week? It is easy to find the sixth term in the sequence in problem 1. However, problem 2 and 3 typically may take you a while to work out. To solve such problems quickly and easily, you can derive a formula to determine the general term, that is, the nth term or the last term in a sequence. Let us consider problem 3. After saving 100 rupees in the first week, John saves 25 rupees every week. Therefore, the common difference, D, in John's savings every week is 25. Thus, the balance in John's account is 100 in the first week, 100 plus 25 in the second week, 100 plus 2 multiplied by 25 in the third week, and so on. Let John's savings in the first week, that is, the first term in the sequence, be A. In this problem, 100 equals A. The common difference, 25, equals D. As you can see from the table, the general form of AP is A plus D, A plus 2D, and so on. If you denote the first term, A, as T1, the second term, A plus D, as T2, the third term, A plus 2D, as T3, and so on, then you get T2 equals A plus 2 minus 1 multiplied by D, and T3 equals A plus 3 minus 1 multiplied by D. You can generalize this to get the 20th term, which is A plus 20 minus 1 multiplied by D. Therefore, T20 equals 100 plus 20 minus 1 multiplied by 25. On solving, you get T20 as 575. In other words, you come to know that John's total savings in the 20th week will be 575 rupees. T20 equals 100 plus 20 minus 1 multiplied by 25. If you substitute 20 with n in the above calculation, you will get a general formula for calculating the nth term of an AP. Thus, Tn equals A plus n minus 1 multiplied by D, where Tn equals last term of the progression, A equals first term, D equals common difference. The number of terms of an arithmetic progression whose A, D, and Tn are given is n equals to